Okay, good morning, and thank you all for being here and showing that you care about security by being in this room. So we're going to talk about how you can show that you care about security using OpenSSF Scorecards for your Dart and Flutter projects. So this is a scorecard badge, and this particular badge is showing a score of 8.2. The scores are out of 10. And so this badge is green because it's a score of above 8. And 8 is pretty good. So that's why it's green. This is a snapshot I took a little while back of the OpenSSF scorecards that we have at @Sign for all of our key repositories. So we consider a key repository to be one that we kind of highlight in our GitHub organization. And if you run down there, you'll kind of see they're mostly green, which is great. Apart from docs kind of there near the bottom, which is a sort of muddy green rather than a bright green. And getting a docs repository to have all of the things that a scorecard needs is a little bit tricky, which is why that one is still languishing below an 8. So hi. I'm Chris Swan. I'm an engineer at @Sign, where we're building a platform for end-to-end encryption based on personal data services. Our customers care about us being secure. And so this talk kind of comes about from the work that we've done to show our customers that we care about security. I'm a Dart GDE, not a Flutter GDE. And so most of what I'm bringing into this talk to make it Dart and Flutter specific comes from the work that I've done and with my colleagues on Dart and Flutter based repositories where we've been applying the techniques that I'm going to go through here. You'll find me on socials as @CPSwan. I'm no longer active on Twitter, but Mastodon and a bunch of other places. You'll find me there. And you'll find links to various other places to find me on the net from chris.swans.net. So in the 40 minutes or so that we've got, this is what I'm planning to run through. So I'll start out with how we were inspired by Google's Dart and Flutter teams to begin this journey. So they sort of started doing this stuff ahead of us. They talked about it, and that kind of provided the inspiration. I'll move on to who the Open Source Security Foundation are and what a scorecard is. And from that, I'll then recommend that you actually start with a different OpenSSF project. So there's a project called All-Star. This was included in the Dart and Flutter material at the beginning. And I think it's a great foundation to lay for doing this kind of work. When you do start implementing Scorecard, you need to pick a repository. And so I'll go through the process of putting a scorecard onto that first repository, and then talk about scaling across an organization. So once you've done your first repository, how can you take what you've done there and reuse it across as much of the rest of the organization as you want to touch? I have found, and if you do this yourself, you will probably find that there's a bit of a kind of 80-20 rule goes on here, that you can get 80% of the impact for 20% of the effort. But that means to get the other 20% of the score, there's a lot more work to be done. And speaking of work, implementing scorecards will generate toil in your organization. And so an important practical consideration when you're doing this is to try and manage the toil of it all and minimize that toil. So I'll touch upon where the toil comes from and what we've been doing to reduce that. So we're here at an event that's fixated on Flutter. And so, how does this relate to Dart and Flutter? Well, for us, it all started with this blog post. And so summer of 2022, so a little over 2 years ago now, there was a blog post from the Dart and Flutter team talking about enabling All-Star and security scorecards on their repositories. So the link to that blog post is in the bottom. I'll be publishing these slides right after I'm done with this talk. And so you should be able to find that pretty easily. I am not going to read the blog post for you. So what you see then is if I go to the Flutter repo, it's got its little badge there. So the badge that I showed at the start, there's the Flutter version of that badge, and you can see that they've got a score of 6.9, which gets them a muddy green color in the badge. Also notice beside it, there's another badge there for Salsa Level 1. I will touch upon that in a little bit. So who are the OpenSSF and what is a scorecard? Well, the OpenSSF is the Open Source Security Foundation. And so this is an organization that sits within the platform of the Linux Foundation. And it's basically got the mission to coordinate efforts about security in the world of open source. If you look at who's involved in doing this, a lot of the kind of instigating energy came from Google. But if you look at who's involved today, it's a pretty broad church of organizations that are doing work in open source and that care about security and want to improve the security of that open source and want to show the consumers of that open source that they're making efforts to make all of this stuff more secure. So OpenSSF now is becoming increasingly visible in various forums. So I see activity on social media. They have events within Linux Foundation events. They have their own community events. They've started to do meetups, and they're very actively showing up at other open source conferences, etc., talking about what they're doing. I guess me stood here this morning is a tiny little sort of fragment of that, though I personally don't have a sort of formal affiliation with OpenSSF. And @sign right now isn't a member of OpenSSF, but it's one of those organizations where even without paying the Linux Foundation dues, it's relatively easy to get involved and participate with the work that they're doing. A scorecard is a holistic set of checks against the security practices within a source code repository. And it's looking at a variety of different areas. So if I go around this circle here, code vulnerabilities, maintenance, continuous testing, source risk assessment, and build risk assessment all factor into the scorecard. And so there's a whole bunch of measures being run, and those measures are then being consolidated into a score, and ultimately that gets you the however much out of 10 and a set of recommendations about what needs to be done to turn that into a 10 out of 10. So I'm talking about Scorecard, but there's another OpenSSF project called All-Star, and that's where we started. I think that's where the Google folk started. And talking to other people in the community, those that did start with All-Star seem to be happy with their journey, and those that didn't start with All-Star kind of wish that they had, because it's one of those things that's really good at putting in the foundations. So All-Star can be found within the OpenSSF's GitHub organization. And if you go to that repository, it has the installation instructions, etc. All-Star is a GitHub application. And so this is something that you install at an organization level. And what it does is it gives you a set of recommendations about configuration of repositories in order to achieve a sort of security baseline. So it'll automatically raise issues and tell you about things like binaries that are in a repository, missing security.md files, and that kind of stuff. And we use this to kind of establish a level across the @sign Foundation organization where we've got our open source. And it was a really good foundation for then building the scorecards from. The work that this amounts to in order to get All-Star to stop nagging you with the automated issues that it generates all the time is a whole bunch of config that you need to do to the repositories and a whole bunch of files that you need to have in the repositories. So that config is stuff like putting branch protection in place. And those files are things like having a security.md to have your security policy there. So I found two tools sort of pretty much essential to putting all of that config and those files in place. So for the config, we use Terraform. I will have some links at the end to some resources where you can go and get other people's Terraform scripts. And that makes it pretty straightforward to get a unified config across the repositories that you're trying to do this to. The other tool that we used is a thing called Git xargs. Git xargs is great at taking a sort of standardized set of files and allowing you to apply them to multiple repos. So it'll take a change set and it'll take a list of repos that you want to apply it to. It'll go and see what pull requests it needs to make in order to accomplish that and then automatically do them all for you. And just about the only problem with that is GitHub rate limits. And the most recent versions of Git xargs have become much better at respecting those rate limits, so it won't swamp your account with too many pull requests at once and then have them all turned around and not happen. So moving on from All-Star then, and it took us probably about 4 or 5 months to implement All-Star and get comfortable with it and for things to settle down. We then moved on to doing our first repository. And so I'll touch upon the experience of doing that. I picked a repository, and I picked what I thought was a good representative repository. So in our case, we have the @server, which is the core implementation of our technology. And I thought I'd start there. So I implemented the scorecard GitHub action, and this is what's happened. It opened hundreds of security issues. So you can see here 128 closed. So that was the issues that have subsequently been closed after all of those had been raised. So you can see on the left there was 5 still open at the time I took this screen grab. So that was like 133 security issues that the scorecard action found in our repo. So closing 128 issues looked like a giant mountain to climb, but in fact, it wasn't as difficult as you might first think. And the reason for that is help is at hand. And so when you implement Scorecard and see the reports, it will link through to tools that are going to help resolve the issues that it picks up. And one of the most frequent issues it's going to pick up is unpinned dependencies. So I love Daria's preceding talk because static analysis is a part of what's done with Scorecard. But I was cringing a little bit because there were no pinned dependencies in the screenshots. And so normally we would be like, users actions check out at v3. And what the Scorecard wants you to do is actually pin that to a SHA. And then you'll see on the right-hand side, there'll be a little comment to tell you about which version of that is being pinned against. And there's this step security tool which will automate that for you. So you can just point that at your repo. It'll pull up the workflows, scan through them, figure out what the shards should be, make a recommended change set, and you can either copy paste that into a pull request or it'll even raise a pull request for you. But it's not just GitHub actions that you need to consider for dependency pinning. So it's going to ask you to pin your dependencies in all of your package managers. So we're talking about Dart and Flutter, so we're going to be using pubdev. You might also be using things like Docker as part of CI pipelines so that you can spin up services or mocks and run stuff against those. And so in each case, there's this kind of push towards dependency pinning. And until you've got those dependencies pinned down, there will be those issues being generated by the scorecard. So that's your first repo. What's involved then in scaling across multiple repos? Well, it's more of this. So it's kind of rinse and repeat, more Terraform and more Git xargs. So things like branch protection, All-Star will have got you to do some branch protection. Security Scorecard will push you to be having much more refined branch protection. In terms of having files in place, Scorecard will be demanding a little bit more than All-Star did. And so there's kind of more work to be done, just making sure all of that boilerplate is where it needs to be. And xargs is a great way of doing that. And of course, more of this, because each repo that you go through is going to have a different set of dependencies, and each of those dependencies are then going to need to be pinned. And so the step security tool comes into its own once again in getting those straightened out. Over time, what you will find is you can probably put a bunch of this as boilerplate into a GitHub template for your repos. And so as you're starting new repos, you can start from a position where all of the bits are in place. That certainly counts for the file stuff. It's a little bit more problematic with config. And I know that there's certainly conversations happening with GitHub about making it possible to template config across an organization and have that to be consistent as well. So 80-20, I think you can get 80% of the score with about 20% of the effort. And so what I've just shown you in terms of getting dependency pinning straightened out using the step security tool will take your scores from, I'd expect initially, if you just take a random repo, it's probably going to get a score in the 5 or 6 kind of mark. And doing just the stuff I've shown you already is likely to get you a score into the mid-7s. So a nice, comfy, muddy green. And then just a little bit more work will get it into the low 8s, and you'll have a nice green badge. And that's a badge that I think any of us can be proud of having on our repos to show that we care about security. Now, how do you get 10 out of 10? The answer to that is essentially you don't. Even Scorecard itself right now has 9.7. And it's kind of, they've tried to do everything to show that they're eating their own cooking and trying to do a good job of security. So it's relatively easy to get most stuff right. And so here is a sort of more recent Scorecard report. And you can link your badges through to these reports so that people can easily see them. And if I look at the top of the report, there's lots of really nice 10 out of 10s there. And so we know that there's no binary artifacts, and we're doing CI tests, and we've got code review in place. And all of that stuff's good. But there will be some residue. So this is from the security tab on GitHub. And it's telling us here that it would like to see more for static analysis. It would like to see more with fuzzing. It would like to see more effort applied to what were previously called CII best practices, now OpenSSF best practices. In the tool, they're still at the moment called CII best practices. So that's what that residue looks like to your users when they see the report. So we're seeing here a little ding on pinned dependencies, and then 5 out of 10 for branch protection, 5 out of 10 for CII best practices, 0 for fuzzing. Fuzzing is a real challenge with Dart because there is not a Dart fuzzer. So Dart itself and Flutter use open fuzz, but that is not a project that is easily applicable to our stuff. And so until somebody comes along and provides a fuzzer, that 0 is going to be a sticking point. We can also put these as radar plots. So if you go to our scorecard page, there's links through to these little radar plots. This was a JavaScript tool that was put together by one of the OpenSSF folk. And I just did a little fork of that with a GitHub page in order to render these. So static analysis. We were just talking about static analysis in the last session, and actually the scorecard doesn't pick up Dart Analyze and Flutter Analyze. It's not yet been trained to look for those. But it's also expecting some other types of static analysis. So one tool that you can use on your Dart and Flutter projects is a thing called OSV Scanner. This is actually written in Golang, and so you have to set up Go as well as Dart in order to make this work. But what it does is it takes your pubspec.lock and analyzes that for any known insecure packages that you're importing. And so anywhere that you're already doing Dart pub get in your CI, you'll have generated a pubspec.lock file, and with that pubspec.lock file, you can run OSV Scanner against it. So this code fragment that I've got on the screen is kind of presuming that you've not already done Dart pub get, but you'll probably already have done that in your CI in order to do everything else that the CI is doing. And so just adding in this one extra little command line will get you to run OSV Scanner, and we'll get that notification of vulnerable dependencies. This is where it gets really gnarly. So before there was Scorecard and a way of doing automated checks, there was this thing called CII best practices. And Scorecard has kind of dragged CII best practices along with it, and they're now called OpenSSF best practices. And it's basically a giant questionnaire that you have to go in and you point it to your repo, and it does a bit of scanning of your repo, but it's a mostly manual process where you say, we're doing these things or we're not doing these things. And so when you start out, you'll get some credit for at least beginning the process. And so you'll get an in-progress badge. And once you've got beyond that to a sort of passing grade, there's actually then beyond that silver and gold. And at each level, it's kind of exponentially harder because you're having to do much more stuff in order to say yes to the questions on the questionnaire. And passing will only get you 5 out of 10. So you need to get the gold badge in order to get 10 out of 10. And that's why nobody has a 10 out of 10 scorecard, because getting best practices 10 out of 10 is kind of impossible. So the questionnaire is long and detailed. And so this is an example of some of the questions. It's like, you know, do you have a policy for new functionality testing? How do you provide evidence of that, etc.? And some sections of it are going to be very hard to accomplish. So not only will you get dinged on a Dart project because you can't do fuzzing, but you'll get dinged within the best practices because you can't do fuzzing. And so there's a lot of sort of duplication between the scorecard and the best practices. And so there's going to be whole sections of best practices where it's really difficult to do this for Dart projects. And as you're going through this, you'll also notice that it's very, very oriented to C and C++. Now, I can understand that. It's kind of C is at the heart of Linux and so much of that part of the open source ecosystem. C is also where it's at the heart of the problem. The root cause of most security vulnerabilities are C memory management. And so a lot of these rules that they've got in best practices are basically don't do the things that we know cause problems with C. And you kind of get to tick the non-applicable thing a lot of the time when you're using Dart, because in any garbage collected language, just so much of this stuff doesn't actually matter. But this is an example of where Dart should have dynamic code analysis, but does not. And so we have to kind of say unmet or stick with the don't know. So I've talked about the work so far in implementing Scorecard, but once you've implemented Scorecard, there is ongoing toil. So make friends with the new boss. Dependabot is going to be giving you a lot more PRs once you've started pinning dependencies. And that makes sense because if in your GitHub action you say actions checkout at v4, then every time there's a minor update to actions checkout, you don't care. It's going to automatically pick it up. But once you've pinned that dependency, every time there's a patch release to actions checkout, you're going to get a pull request. And you'll have days where there's just mountains of pull requests. So if you want to have a really busy GitHub contributor graph, do this. You'll be doing like about 4,000 contributions a year without having to write a single line of code. So this is an example from a docs repo. So no code to maintain here. And you can see, there's just bump after bump after bump for actions checkout, GitHub code QL actions. So checkout is used within Scorecard, as is code QL action. So these are this is toil generated by Scorecard itself. This is a code repo, and that's an eye chart, and I don't expect you to be able to read it. But it's just, when you start dealing with actual code, well, of course, now there's a ton more PRs. And as I mentioned, Scorecard's own dependencies can change with annoying regularity. And so every repo that you put a Scorecard into is going to at least have this kind of background radiation of toil and Dependabot PRs. The other thing to watch out for is base dependencies can be amplified. So let's say you're using the Dart Docker in order to run some Docker-based services. That's based upon Debian, and so every time Debian gets bumped, so does Dart. And so what you'll see here is the Dart tag hasn't changed. So I had a bunch of these this morning. So it's still Dart 344 as a stable release, but the SHA has changed because the image has changed because it's got a different Debian in its belly. And so you end up then with a whole bunch of PRs. Now, not very long ago, I would wake up to a stack of PRs, and they'd kind of individually make their way through CI and have to be merged, and that was extra painful. Things have got better. So I had to change this slide yesterday because it said it was about beta functionality, and this came out of beta just a few days ago. So when you're setting up Dependabot, for most of the dependencies we work with, we have to actually point it to particular directories. So for GitHub Actions, you can just kind of go / and it'll find the GitHub Actions, but that's because GitHub Actions only live in one place. Whereas other dependencies like Docker files and like pub specs can be all over the place in your repository. And so you have to point Dependabot at where they are. And it used to be that you had to have a separate section with each different directory. And that was painful because it meant that each different section would generate its own different PR. What changed recently is there's now, instead of the directory keyword in the YAML, we can now have directories, and we can pass in a list of directories, and we can give all of the locations here for, say, our pubspec files. That on its own will not consolidate your pull requests. So you have to combine that with the groups functionality. And in this case, I've just created a group that I've called pub. I've given it the pattern of star. And what that'll do is it'll bundle up now all of my pub pull requests into a single pull request. So this morning, for that Debian change that rippled through into Dart, I got one pull request for 6 changes. Whereas just a few weeks ago, I'd have got 6 pull requests, and then I'd have had to have manually rolled them up. There will still be times when you want to do a manual roll-up, and this is an example of a script that can do that for you. I've got a little gist that's got this script in it, and there's a blog post about it as well. And that kind of happens when you might have repos that have got multiple dependency managers all being updated at once. So if it's a busy day for GitHub Actions and a busy day for Pub and a busy day for Docker, then even if you've managed to consolidate those, you're still going to have 3 pull requests. Do you want to be waiting on 3 sets of CI before merging those? No. So much better to merge them into 1 pull request, 1 set of CI, 1 merge, and a lot less waiting around. So I've put in a bit of bonus content here. The agenda was about Scorecard, but there's some related stuff that I think is much more kind of coming into visibility and has been part of our work at @Sign in recent months. So software bill of materials is where you can tell people what's inside what you're shipping to them. And there are standardized formats for this, which can be used by security tools. The OpenSSF has a tool called Guac, and that will ingest a software bill of materials, and it'll ingest a vulnerability feed, and it'll say, okay, we know that these vulnerabilities are going to be found in this thing. Software bill of materials is becoming really important, especially in the US, because of an executive order a few years back that's mandating the federal government that they should have a software bill of materials for software that they're acquiring. So with managed languages like Dart, it's actually really easy to generate a software bill of materials. Basically, anything that's got a package manager that generates a lock file, that lock file can be transposed into a software bill of materials. And there's 2 popular formats, one called SPDX, which comes from the Linux Foundation, and the other called Cyclone DX, which comes from the sort of open source vulnerabilities world. We can use a tool called Sift, and it'll scan the pubspec.lock, and it'll generate the software bill of materials. So we can make an SBOM with Sift, and we can understand it with Guac. The other thing that we can do as kind of part of our continuous delivery pipeline is we can generate hashes, and then from those hashes, get a build attestation. This is another thing that was in beta until a few days ago and has now been kind of full-scale launched by GitHub. And so when you do these during a build, it'll generate a whole bunch of these attestations, and these are the screen grab of the links to those attestations. And so if I click through into one of those, we can see that I was building a package with some binaries here, and it's giving me a whole bunch of provenance information. So it's showing an attestation of, this was built in a kind of knowable way. So we can go one better than that. And you might recall when I showed the screen grab of the Flutter repo, it had this little salsa badge beside the scorecard badge. And so salsa is supply chain levels for software artifacts. And what it's about is showing evidence that you've built the stuff you're shipping in a kind of well-known way and that nobody's been able to interfere with that build. And there are different levels, so levels 1, 2, 3, for different levels of assurance around that. Within GitHub, it's actually pretty straightforward to go all the way to level 3. And so all you need to do is incorporate this salsa GitHub generator action into your continuous delivery pipeline, and it will generate an attestation for you, and that attestation will be at salsa level 3. So if we peek inside that attestation, the attestation itself goes into a file called multipleintoto.jsonl. And if we peek inside that, we can see here that I'd created some software bill of materials, and I'm getting digests within the attestation for the software bill of materials that were created as part of that build process. So somebody can come and inspect your build afterwards and know that it was a good, consistent build and nothing's been fiddled around with. So altogether, this gives what I call the software supply chain trifecta. So SBOM, SALSA, and Scorecard all brought together are an even better way of showing that you care about security to your customers. The other thing that happens here is as you're building your SBOMs, you can generate attestation that those SBOMs are authentic for when you built them. And in generating those attestations, that will create a signed release, and the scorecard will go up for you having signed releases. So this is how at Sign we got our scores from kind of mid to high 8s into the low 9s, was by adding signed releases to our build pipelines doing this. So a quick review then. Our journey at AtSign started with the adoption of the Dart and Flutter team and them talking about it. And so, these scorecards are part of our ecosystem that we're working in already. And because there's other people doing work on this in the ecosystem, you can kind of peek over at what they're doing and copy paste some of that into your own work. An OpenSSF scorecard can show that you care about security to your customers. All-Star, the GitHub app, gives you a really good starting point for that journey. It provides a solid foundation for work that you do on Scorecard. Pick a representative repo first as a way of getting a hang of what's going on. And then having fixed up that repo and got a score that you're comfortable with, you can take what you've done there and automate that process across the rest of your organization. I think it's about 20% of the effort to get 80% of the score. And 80% of the score is an 8 out of 10 and a nice green badge. So it's relatively straightforward to get to that point. It's uphill work from there. Getting from 8 to 9 has been a bunch of work for us over the last year or so. And if you look at what Scorecard itself has done to get to 9.7, they are, by definition, the creators of that stuff. And it shows that getting a 10 out of 10 is really, really hard. Scorecards do, unfortunately, create ongoing toil, and that needs to be minimized. And you can minimize a bunch of that now with some of the newer features in GitHub Actions. But there's still other kinds of automation that I would like to be able to do. So if I think about a bad day of Dependabot PRs, I'd love to be able to say, that one in that repo is an instance of the class, and just if I've approved that one, I approve them all and merge all the rest of them. And that particularly applies to kind of GitHub Actions changes, which are kind of not really having a direct impact on the code. So it would be good to have tools that helped us review once and deploy many times in order to reduce that toil. I always like to finish with a call to action. And my call to action for this room today is run the Scorecard command line tool against one of your own repos. So if you go to the Scorecard repo, there's a section of the README for the command line tool, and that'll show you what the score is without you having to kind of fully implement it and do the GitHub action and all of that kind of thing. And once you know what the scores are looking like, you can then make an informed decision about how much work you want to do to make them good. By the way, anybody else can run this tool against your repo as well. And so maybe your customers are already doing this. There are some resources. So I did a blog post back at the end of 2022 on our journey implementing Scorecard, and a little while later on some of the roll-up stuff to minimize toil. We have a section of our GitHub org documentation called @GitHub, which talks about how we use GitHub and many of the tools that I've talked about today. And Varun Sharma, who's the founder of Step Security, he did a demo of this stuff at QCon London last year. And so he's got a demo org on GitHub, which has got some good Terraformy bits in it and stuff like that. Thank you, everybody, for your time. It's really good to see a decent room full of people interested in security. And hopefully we've got a minute or two left for questions. Thanks.